Hi there, welcome back. This is page number 2 of your Unit 1 review for your test over functions in pre-calculus. Okay, it starts out with domain. We want the domain of this square root function. Okay, this is one of our functions that has a restriction on it. Okay, so you should know from class that the restriction on a square root is that the whatever is underneath your radical cannot be negative. Okay, it can be 0, that's fine. It can be positive, that's wonderful, but it can't be a negative. So we have to make sure that whatever we have underneath your equation is non-negative, greater than or equal to 0. So only the stuff underneath the radical. We don't care about this plus 4 out there. It doesn't help us with our domain. That does affect the range, but we are asked for the domain. So we only do the stuff that is affecting the domain. And now we have to solve our little equation, our little inequality. Okay, so because I'm forgetful, I don't know what the rules are, so I try and keep x positive. So I add 3x to there, and I get that x, or 3, has to be greater than or equal to x. Okay, so that would be your inequality. It has an inequality symbol in it. That must mean it is one of those things. But how about as an interval? So as an interval, I'm going to read from right to left, from the x. This says that x is less than or equal to 3, which means all the numbers smaller than or equal to positive 3. So negative infinity is the ultimate smallest number. And I'm going to run that right up to 3, and because it's or equal to, I will have a bracket as my interval. All the numbers less than positive 3 are from negative infinity to positive 3. Okay, so one of your restrictions is for square roots. You always set your radicand, the thing underneath your radical, greater than or equal to 0, and solve. Okay, number 6, we are trying to evaluate this, f plus g at 5. Okay, so this is a combination. It wants to know what is f of 5 plus what is g of 5. So we're going to evaluate 5 at both of these functions, and then you're going to add them together. So first, let's plug in 5 into each. So we're going to plug 5 into here. So here's your f, the square root of 9 minus 5 plus 2, plus, here's your g, 2 times 5 squared, minus 7 times 5, minus 5. So we're going to evaluate each of these separately, one at a time, of course, and then we will come back with a final solution. So 9 minus 5, that's 4. The square root of 4 is 2. So 2 plus 2 is 4. So f of 5 is 4. Plus, okay, let's do the same thing over here for g. 5 squared is 25. 25 times 2 is 50. 7 times 5 is 35. And then, of course, minus 5. So 50 minus 35 is 15. Minus 5 is 10. So your final answer, what is 4 plus 10? 14. Okay, so you evaluate each of those separately by plugging 5 into their respective equations, and then we add those two things together. Okay? Okay, let's look at number 7. So here we have the graphs of f and g. Okay, so it says f is increasing on the intervals from -5 to -2 in parentheses, which is perfect because intervals of increasing should be in parentheses, and from 2 to 7. So here we have the graph going in an upward direction. And let's see, this is -1 and -2. So sure enough, it looks like that's true from -5 to -2. and then 2, 3, 4, 5, 6, 7. Yes, the graph is also going up from 2 to 7. So this one is true. Both those things are true. Okay, f of x equals g of x. That means that our graphs are crossing or intersecting only at x equals 5. So let's see, nothing, nothing, nothing. Boom, right here's where they cross. Sure enough, x equals 5. That one's true also. F of x is greater than g of x. That means the f graph is above the g graph only on the interval from 5 to 6. So let's see, here's 5 to 6. Yep, looks like the f graph is in fact above the g graph. So I would say all of those statements are true. Okay, so those are all going to be true statements about your graph. Excellent way to analyze. Okay, number 8, we're given this graph over here, and we want to evaluate. So remember, this is your x value, and we're trying to figure out what the y value is when x is -1. So when x is -1, y has a value of -2. So put that in there. This equals -2. F of 6. So when x is 6, y is, down here, the closed dot, which means y is -5. Okay, when x is +1, y is up here at +2. So we're finding y values from your graph for every x value that they talk about. So f of -5. So when x is -5, we're up here and we notice there's an open circle. So that means that there's no y value, no specific assigned y value for that particular x value. So we say is undefined. Okay, not equals undefined, but is undefined. Or you could say does not exist, DNE. The y value when x is -5 does not exist. And then f of 2, when x is 2, y is up here. So maybe 2.5 might be a good estimation. So if we're going to estimate, we should, of course, use the squiggly lines rather than an equal sign. Right? Approximately 2.5, because I don't know for sure. Okay, part F, find the x values for which f of x. So when y is 2, right? So we're looking for when y is 2 on the graph. So here is your y equals 2 line. Okay, it crosses one time here. So I don't know, about 3.5 maybe something. So x is approximately -3.5 maybe. Okay, that would be the place there where they intersect, and we come and we see it intersects here where x equals 1 and there where x equals 3. So at approximately -3.5 and then +1 and +3 are all your places on the graph that have a y value of +2. Remember, h of is talking about a y value. Okay, and then number g, suppose g is this graph. For how many values of x is this true? So remember, this means where do they cross? So we're looking for how many times do this graph cross. So we're going to come and we're going to sketch our square root graph on your grid. So we have been moved 3 units to the right, that's what the -3 means, and 2 units down, and then this one means our graph is going to open to the left. So 3 right, 2 down, and opens to the left. So from your origin, 1, 2, 3 right, 1, 2 down, that is your new origin point, and it opens left. So we go 1 left and 1 up. We go 4 left, 1, 2, 3, 4, and 2 up from your origin, and then we go 9. Well, 9 fit on there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Sure enough. So we're going to make our graph go to the left, and it said how many times does it cross? So we can analyze this. I see that it crosses once right there, and it crosses another time right there. So we're not asked to solve what is the x value, we're just how many times does it cross. So there are 2 values of x where they cross. Okay, not where are they, but just how many times. Okay, so make sure you're reading your question and answering the question that they're giving to you. Okay, there's page 2, and now for our last page, page 3, which looks like this. It starts off with, we have two functions, and we want to know for what values are they equal. Okay, so since we don't have a graph, we can't see how many times they cross, so we have to do the algebra, which means we're actually going to set these equations equal. X squared minus 3x plus 2, when does that equal 4x minus 8? Okay, so because we have a x squared, an x, and a number, we're going to make this into a quadratic and solve it. So everything is going to come onto one side of our equal sign. We're going to minus the 4x. So we get minus 7x, and we're going to add the 8's to get plus 10 equals 0. Okay, so now we have a quadratic that we're going to have to factor. So in our brains, we need to think about what numbers multiply to give us positive 10, and at the same time add to give negative 7. And hopefully you see those numbers as being, let's see, negative 5 and negative 2. So two negatives multiply to give us a positive, and they add together to give you a negative. So our factors are x minus 5 and x minus 2. So our equals 0, not equal to 0, equals 0. So we said each of our factors equal to 0, so x minus 5 equals 0 or x minus 2 equals 0. So x is either positive 5 or positive 2. So those are the two values of x where our equations will be equal. In other words, that's where your graphs cross, at positive 5 and at positive 2. Okay, number 10. Here we have, once again, a domain. Now, usually, for every cube root, the domain is all reals, right? There's no restrictions on a cube root. But here we have a fraction inside of a cube root. So we have to deal with the fraction as if it were really there, because you can't take the cube root of an undefined value. So as long as we keep that defined, then we're fine. So the denominator can't be 0, so we're just going to solve this equation as if we were solving a normal equation, because it is really a normal equation. So x cannot be negative 1/3. Any other number will be fine, all real values except for negative 1/3. Okay, so as an interval, that means we're going to write it with our parentheses and our infinity. So we're going to exclude negative 1/3 from the domain. Okay, so that's like as if we had a circle around negative 1/3, and all the stuff to the left is from negative infinity, and all the stuff to the right is out to positive infinity. But this is how we write it as an interval, excluding negative 1/3. Okay, number 11. Here we have a table of values, and we're given this thing called h. So we have an equation that happens to be an absolute value. When does x, what values of x does h of x, our equation, when does 2x plus 3 equal g of f of negative 1? So we're saying, when is it equal to this composition? So we're going to use our table in order to figure out what that value is. So first we look at f of negative 1. So our x value is negative 1 in the f. So here's x equals, here's negative 1, and our y value is negative 2. Okay, so this is g of negative 2. So that means we're going to go down to here. When is negative 2 your x value? And our y value is 7. So g of f of negative 1 is positive 7. So we're really asking the question, when does our absolute value of 2x plus 3 equal 7? That's what we are really trying to evaluate. So hopefully you remember how to do absolute values. We split these into two equations. One equation is where 2x plus 3 equals normal 7, and the other is where 2x plus 3 equals negative 7. So we have the positive of your answer and we have the negative, because absolute values can be either. So we're going to subtract 3 and divide by 2. X equals 2. That's one of the values. And then we're going to subtract 3 and divide by 2, and x equals negative 5. So there are two places, there are two x values, where our absolute value will be the same as this composition value. Okay, and that's what we're really trying to find. Okay, moving on, number 12. Here's your f, there's your g. Then we're going to have some third equation p that has, right, as a combination of these. So we have 2x times your g function, which is 4x minus 8, minus the f function, x squared minus 3x plus 2. Okay, so we're going to find an equation, which means we have to do all that algebra in order to simplify this to one equation with one of each term. So let's do our distribution. So here's 8x squared, and 2x times minus 8 is minus 16x. And then we're going to distribute the negative. In other words, change all the signs of our second thing. So minus x squared plus 3x minus 2. And now we have some like terms. 8x squared minus 1x squared is 7x squared. We have minus 16x and plus 3, which is minus 13x, and then I have a minus 2. Okay, so this is going to be the p of x equation, right? That's what I called, the equation up here was called p, so that's my equation for p of x. Whew, okay, it's more functional notation stuff. All right, and lastly, we have a piecewise function. So we want to evaluate f of negative 4. The first question is, when x equals negative 4, which of our three constraints do we use? Okay, that question mark goes to the entire thing, not just to that problem. So negative 4 is here. Negative 4 is less than negative 2. So we're going to evaluate using this quadratic equation, x squared minus plus 3x. So this is equal to negative 4 squared plus 3 times negative 4, okay, which is 16 minus 12. So f of negative 4 is 4. Okay, same with 0. Which constraint does 0 fall under? Well, 0 is greater than negative 2. So we're going to evaluate it using this equation, the negative of 0 plus 6, which is the negative of root 6. And that is a fine answer. You can leave it like that. You do not have to change that to a decimal. Okay, what about f at negative 2? Well, at negative 2, it says the answer is always 5. So at x is, when an x value of negative 2 means we have a y value of 5. Nothing to evaluate, just write it down. Okay, is f of negative 2 less than f of 4? Well, we've already done this evaluation, so now let's just compare them. Remember, f of negative 2 is 4 from here, and f of negative 4, no, switch that. Switch that around. F of negative 2 is 5, and f of 4 was 4. Right? So f of negative 4 is 4, f of negative 2 is 5. Is this true? No, this is not true. 5 is not less than 4. Right? So we are comparing these y values for particular x's. E, is f of 12 greater than f of negative 3? Well, that's going to require some brain power. F of 12 goes into here. The negative square root of 12 plus 6 is the negative square root of 18, which is approximately negative 4 and change, right? Because 16 is 4, 18 is a little bit bigger than that. Let's just call it 14.19. Okay. All right, estimating, great. Negative 4.19. Is that bigger than f of negative 3? Which means we're going to use this guy. Negative 3 squared plus 3 times negative 3 is 9 minus 9, which is 0. Okay, so is negative 4.19 greater than 0? And the answer is no. So with piecewises, you have to use the equation that matches up with your constraints. Right? It has to fill into that bubble, if you will. It has to be able to be matched up. So here is your entire review. Hopefully you study and you'll do fantastic on your test. Thanks. Goodbye.